Welcome back to this course for the topic, the equations with homogeneous coefficients. So let's have another example regarding this. Say we have the differential equation x minus y tangent or arctangent y over x. Dx plus x arctangent, this is y over x dy is equal to 0. So we have once again this form where m is a function of both x and y, and we have n function of x and y dy here. Okay, but as you can see here, we cannot easily separate these y and x variables. So let's try the equations with homogeneous coefficients. So our first step is to substitute a variable, say w is equal to y over x, or y is equal to wx, and then from here we have our dy is equal to w dx plus the second times derivative of the first. So our next step is to substitute these facts in order for our differential equation to be in separable. Okay, so we have to substitute the value of y and the value of dy. Okay, so let's try. So we have x minus our y is wx, and then our arctangent y is wx all over x, then dx. This whole term is multiplied by dx plus x arctangent. Once again, our y is wx all over x, and our dy is w dx plus x dw, and then this whole equation is equal to 0. So as you can see here, we can now cancel this out. X over x is just 1, and then we may now simplify this. So we have x minus wx arctangent w dx plus x arctangent of w, then w dx plus x dw is equal to 0. And from here we can now distribute the dx. So we have x dx minus wx arctangent of w dx plus let's distribute this term. So we have x or wx arctangent w dx, then here we have plus x squared arctangent of w dw is equal to 0 Tama ba? So we have x dx minus wx arctan of w dx plus, yeah. So from here, let's try to simplify it further. So as you can see here, we have negative and positive wx arctangent of w dx. So negative 1 plus 1, so we need to cancel this out because this is 0. So what we've left here is x dx plus x, this is squared, squared arctangent of w dw is equal to 0. Okay, and then let's make this, let's separate the variable x from variable w. So we need to divide both sides by x squared. So we have the x all over x plus, this is cancel out, arctangent of w dw is equal to 0. And from here, we have now a separable equation. And as we remember that our next step, if we have this case, is to integrate both terms. So we have the integral of the x all over x plus the integral of the arctan of w dw is equal to 0. Okay, so let's now perform the integration. So the integral of this is simply ln of x, and for this one, let's try the integration by parts. So we have, using integration by parts, let us let u is equal to this arctangent of w, because we know that the derivative of this is just dw all over 1 squared plus w squared. Okay, you need to review your calculus 1 and calculus 2. And then our v is, of course, if we let this as our u, then this is our, dv dw. And then for the integral of this, so we have v, and then from here we have w. Then using the integration by parts, we have the uv minus the integral of v du. uv minus integral of v du. So we have our u is arctan w uv. W arctan of w uv minus the integral of v du. One plus w squared. Okay. Then from here, let's copy this ln of x. So we have ln of x plus w arctan negative 1 w minus, so since we have w squared here and we have w here, so the derivative of this is 2w dw, but we have WDW, so we only need to divide it by 2, and then ln of uh, okay, ln of 1 plus W squared, and then our plus C. But since we have ln here, let's use once again the ln of C. Then we've already have our general solution, but need to bring back the value of W. W is equal to y over x from our substitution last time. So we have this. We have W is equal to y over x. So we have y over x. So we have ln of x plus our W is y over x, or tangent of y over x minus 1/2 ln of 1 plus y over x squared is equal to ln of C. So this is now our general solution. But of course, you can also simplify this further. And if you simplify this, you can have a 2y arc tangent y over x is equal to x ln of c squared y squared plus x squared all over x to the 4. Okay, so I'm letting this simplification to you, and you may try solving it on your own. Okay, so let's review once again. We have this equation, but we cannot solve it using the separable equation. So we will do the substitution of the variable W, and then we substitute it on our main differential equation. Then right after that, we've come up with the separable equation and perform the steps of separable by integrating this by separating each term, and we've solved it using the rules in integration and techniques, which leads us to the general solution of this term. Okay, so that's all for this video. See you next time.